Okay, so picture this. How do you get a brand new, cutting-edge fighter jet to talk perfectly with a ground control system that was built, say, 20 years ago? I mean, they're built on completely different technologies, maybe by totally different teams. Well, in this explainer, we're going to demystify the ISR, and no, not the tax agency, thank goodness. We're talking about the official rulebook that guarantees these incredibly complex systems can communicate flawlessly, every single time.
So yeah, how on earth do they do it? It's definitely not magic, and you can't just cross your fingers and hope for the best. It really comes down to a kind of digital diplomacy. It's this painstakingly detailed agreement that acts as a universal translator and a super strict rulebook for how these machines are going to talk to each other. You can think of it like a really formal handshake. Before a single bit of data is exchanged, the two systems have to agree on the exact terms of their conversation. And look, this isn't just a simple hello. It's an entire protocol, and it's governed by an incredibly specific, totally rigid set of rules. So here's our game plan. First, we're going to unpack that whole handshake concept. Then we'll dissect the anatomy of the specification document itself. After that, we get into the really cool part, the nitty-gritty rules of engagement. And finally, we'll look at how engineers actually prove it all works with testing and something called traceability.
All right, Section 1, the handshake between systems. Before we get lost in the weeds, let's just zoom out and establish the what and the why. What exactly is this formal rulebook, and why is it so absolutely fundamental for building these kinds of complex systems?
The official name for this rulebook is the Interface Requirements Specification, or IRS. And yeah, I'm going to say it again, not that IRS. According to the source material, this document's whole job is to specify every single requirement needed for two or more systems to talk to each other. It is, for all intents and purposes, the definitive blueprint for communication.
And here it is. This is the actual military standard we're digging into. And yep, it's from 1999, and I know it might look a little dated, but trust me, the principles packed inside are absolutely timeless. This is the very bedrock of reliable systems engineering.
So what's its real purpose? Well, the IRS becomes the single source of truth for everybody involved. Without it, you'd have different teams building stuff based on different assumptions, which you can imagine leads to total chaos. Instead, this one document guides the entire design of the interface, and just as important, it defines the exact tests that will prove it works the way it's supposed to. And that brings us to Section 2, the anatomy of the specification. As you can probably guess, a document this critical can't just be some chaotic mess of notes. It has to be incredibly well organized to make sure there is zero ambiguity, especially when you're dealing with systems where failure is not an option.
The standard actually demands a super rigid, consistent structure. It dictates everything, from how the title page looks right down to the page numbers. And that standardization is so crucial. It means an engineer from one company can pick up a document from a completely different team, maybe years later, and know exactly where to find the info they need. No time wasted trying to figure things out.
Now check this out. This is what I find absolutely fascinating. Look at this quote from the source document. Even way back in 1999, the standard was encouraging automated techniques and defining a document not as paper, but as a collection of data. I mean, how forward-thinking is that? They were basically predicting the digital, database-driven future of engineering we live in now.
All right, let's get to the heart of it all. Section 3, the rules of engagement. This is where the true power of the IRS really shines. We're moving from the structure of the document to the specific, granular rules that define every single tiny interaction in that handshake. And to really get a feel for the level of detail we're talking about, let's just look at what it takes to define one single piece of information. It's not nearly enough for one system to just, send the altitude. The specification demands absolute, unambiguous precision. And this slide just says it all. For every single data element that gets passed between systems, the developer has to answer a whole checklist of questions. What's its technical name? Is it text, an integer, a floating point number? What are the units? Are we talking meters or dollars or nanoseconds? What's the required accuracy? Literally, nothing is left to chance. So let's break down why this kind of precision can literally be a matter of life or death. If the data type is wrong, the system crashes. Simple as that. If the unit of measurement is off, like one system is using meters and the other is using feet, you get catastrophic errors. That is famously what caused the loss of the Mars Climate Orbiter. And for real-time systems like radar, if the timing isn't perfect down to the millisecond, the data is completely useless.
And the rules go way beyond just individual data points. The IRS also defines the entire communication protocol. What frequency are we going to use? How are the messages formatted? How do the systems control the flow of data so one doesn't totally overwhelm the other? It even gets into protocols for error recovery and security. It's the whole shebang, the complete conversation guide. So, you've spent all this time writing this incredibly detailed rulebook. Great! Now for what might be the most critical step of all. Section 4, Testing and Traceability. How do you actually prove that the engineers followed the rules and that the interface works perfectly out in the real world? Well, the standard lays out two main ways of doing this. First, you have demonstration, which is pretty much what it sounds like. You just watch the thing work. You can see with your own eyes that it's doing what it's supposed to. But the second method, test, is way more rigorous. That requires hooking up special equipment to collect hard data and then analyze it later to prove, with cold, hard numbers, that the interface meets every single requirement. And this all leads to this core principle called requirements traceability. Think of it like a detective's evidence board. You're creating this unbroken chain that links every single requirement in that IRS document to the specific chunk of code that implements it, and then to the exact test that proves it works. It's the ultimate accountability check. Nothing gets missed. So if you take one thing away from this, it should be this. An Interface Requirements Specification is not just some boring technical document. It's an enforceable contract between technologies. It's the powerful tool that prevents misinterpretation, it eliminates ambiguity, and it ensures that these complex systems can talk to each other with the kind of reliability that mission-critical operations absolutely demand. And that leaves us with a final thought. A question for you to chew on. In our modern world of super fast software development, a world filled with plug-and-play APIs and constant updates, is this level of formal, painstaking details still necessary? Or does the relentless pace of innovation today demand a totally different, maybe more agile approach to making systems talk?